like, share, and subscribe to my YouTube channel. Thank you for your support.
For this video today, we're going to discuss the solution to the mystery from the previous video. In addition to the exercises for Chapter 5, we will also discuss them. Hopefully, you enjoy this video. Thank you.
Okay, welcome back. This is Jonathan Goldfish again. So, for this part 2 of the Chapter 5 Trigonometry, we are going to discuss about the last part of this chapter, which is the angle between the two straight lines by using the terms tangent. Okay, so it is the time for us to solve for the mystery questions. Okay, it's not the question, but it's the mystery that we have implied from chapter 3's coordinate geometry. Okay, given that there are the two straight lines, okay, with each angle is subtended from the horizontal line. Okay, I know it's not always the positive x-axis, but this is the best illustration in my deem. Okay, so this is the theta 1 for the first straight line. This is the theta 2 for the second straight line. Okay, but what we want is the angle between the two straight lines, which is this angle. So to prove this, I must have the good drawings, not the good drawings, but the good diagram illustrations, okay, for your better understandings. So what you can see is, since there is a horizontal line which is parallel to the x-axis, so what we know is the theta plus theta over 2, the second theta is equal to theta 1. Okay, so why these two angles are the same? Because of this and this, there's a dotted horizontal line is parallel to the x-axis. So therefore here is theta 2. Okay, and you may simplify it, modify the relations into theta equals to theta 1 minus theta 2. And next, this is the key for the mystery, which is the use of the identities from your A2 syllabus. Okay, it is under the same subject 9709, and it is the paper 3, pure mathematics 3, chapter 3. Okay, which is the Trigo identity. Stay tuned for my further updates. So by using the tangent, this formula, the double angle formulas of the tangent, okay, so tangent theta 1 is gradient 1, tangent theta 2 is gradient 2. Okay, sorry, there's a mistake of this should be line 2 and this should be line 1. Okay, there we go. So this is not an assumptions. Sorry, that's my mistake. This is conclusion. We can confirm that gradient is tangent theta, where the theta is the angle subtended from the horizontal line. Okay, so for each particular angle, you may substitute it as its gradient, which is m1 minus m2 divided by 1 plus m1 times m2. Okay, so to find the angle between the straight lines, move to the right hand side to get arctangent. So therefore this formula has proven. So proven. Okay, okay, yeah, we have solved the mystery from the chapter 3 already. Okay, so this has ended. Alright, so we have finished the discussion of the lecture of the chapter 5 trigonometrics. So now let's move on to the exercises, shall we? Alright, time for the exercises for chapter 5. Okay, so as usual, as the past, okay, the first few questions are from the course book 9709, of course, as well as the past years in the behind. Okay, at the behind. But I won't discuss this question for you because I'll only discuss 14 questions exactly. Alright? Because the length of the questions is way too much, and for the rest of questions, I need you to try it out by yourself, okay? So let me select. Let's start from question 2. Okay, question 2 is from the course book. Find the exact value of each of the following. Okay, let's start from A. Alright, so as you can see over here, I've copy and paste the table from the notes above, okay, for the exact value of the Trigo ratios for the 30 degree, 60 degree, and the 45 degree. Okay, why it is important for you to memorize it? Because it is useful and beneficial for you to answer the questions that is regarding exact value. So let's start from A. Sine 30 degree times the cos 60 degree. So what is sine 30 degree? You should aware that it is half. So this table, this exact value, is actually the definition of trigos of the angles by using the unit circles. Okay? And what is cos 60 degree? It's half as well. Alright? So as we know that sine theta equals to cos 90 degree minus the alpha. Right? Where theta equals to 90 minus alpha. So therefore, theta and alpha are both complementary angles to get the 90 degree. Right? 90 degree or pi over 2. So yeah. The answer for A goes to 1/4, which is 0.25. Okay? But I strongly encourage you to write it in the fractional form for your understandings. Okay, to avoid the confusions. So for the B, sine square 45. So recall that what is the meaning of the sine square or any trigo, the square of the trigo. Okay, this means sine theta bracket or then square. Same for the cos and tangent. Okay? So, sine 45, determine the exact value of sine 45 first, and then you take the square. So it is sec2 over 2, and then square. So using the indices rule, the square root of the square root of 2 is 2, and then the square root of 2 is of course 4. So it's half after you simplify it. So the answer is half. Okay? So sometimes the actual external exam questions requires you to leave your answer in the exact value form. Okay? But it is mandatory for you to perform these workings. Okay? Sometimes it is mandatory for you to perform this step. But in the middle of the process, you don't have to show this. Okay? Because this might make you confused. Okay? So C, sine 45 degree plus cos 30 degree. So following the tables that you have memorized, sine 45 degree, sec2 over 2 plus cos 30 degree is sec3 over 2. So if you wish, you can factorize the half outside. So you will have half times the bracket of the square root of 2 plus sec3. Sec2 plus sec3. Okay? It is, so as you can see, my exact answer is neat and nice. Okay? So yeah, let's move on to the part D. So part D is the fractions of the trigo ratios. sine 60 degree divided by sine 30 degree. Okay, sine 60 degree, sec 3 over 2. Sine 30 degree, it's half. So what you can see is the half and the 1 over 2 can be cancelled out. So you will left sec 3. Okay? E. Sine square 45 degree divided by 2 plus tangent 60 degree. So, what is sine square 45? As we have determined from B. Okay, which is half. So just plugging half in the numerator. So for the denominator is 2 plus tangent 60 degree sec 3. Okay? So this is 1 over 2. So we can move it downwards. It is 4 plus 2 sec 3. But if you want to make your sec on the numerator, what you can do is carry out the conjugation. So just multiply by the 4. The plus sign changes to negative sign as the denominator and numerator because to satisfy its equality. Okay? So this is 16 minus 12. Okay? So it's 1 plus half sec 3. So, you see, this answer is way more neat and nice compared to the answer of this one. Right? Okay, spot by yourself. Okay, for F, that is the last part among this question. Okay, give me some time to copy out the question first. So for the part F, you don't have to give the exact value of the sine 30 and cos 30. It's because of there's a sine square and the cos square, provided these two angles inside are both the same. Okay, so this is so-called Pythagoras identity. So just put 1 divided by. Okay, so for this is the double angle formula that you need to learn this from your A2 syllabus, which is the pure maths 3. Okay? So for this, you still have to put its exact value, which is sec 2 over 2. I know that the sine 45 degree is exactly and numerically the same as the cos 45 degree, but in this question, it only touches AS syllabus. Okay? Try not to touch the A2 one. Okay? So as you can see that the 2 can be cancelled out. Square root of 2 times square root of 2 is 2. So 1 over 2 over 2. So which is 1 as the final answer. Okay? So yeah, that's the end of the questions so far. So let's move on to the next question. Okay, move on to the next question, which is the question 3. It is from the course book. Okay, in each part of this question, you are given the base angle. So the condition of the base angle is from 0 to 90 degree, or from 0 to pi over 2. Okay, so for this interval is for the angle in degree, and the next row is for the radians. Okay, so let's check. Let's start from A. Given that its base angle is 55 degree, but what the part wants is the second quadrant. Okay, so given that in the Cartesian plane, okay, it consists of 4 quadrants. Start from the first quadrant, is everything is positive, so this is the first quadrant. Second, third and fourth. Okay, so this is the second quadrant. So you have to draw a Cartesian plane by yourself. No need to be too accurate, but freehand. At least you must draw out to know that what is the angle that you want to find following the particular intervals. So it wants the second quadrant, highlight over here, and 55 degree. Alright, so which means this theta is the angle subtended from the positive x-axis to a half line, which stops at somewhere, okay, to get the angle subtended. So to get the theta for A, okay, for the angle subtended by the straight linear lines, which is 180 degree minus 55 degree. This is the angle we want to find from second quadrant. So it's 125 degree. That's all for this question. That's all for this part. Okay, for B, 20 degree. And third quadrant. So watch out for the intervals from negative 180 degree to 0, which means the interval is only between 3 and 4. Why? It is the negative angle, obviously. Okay? So it not only involves 3 and 4th quadrant, third and fourth quadrant, and it wants third quadrant. So which means the angle that we want to find for the B is actually the negative of 180 degree minus its base angle, which is 20 degree. So this is the theta that we want to find. So we will get negative 160 degree. Okay, so next time when you are dealing with the solutions of the angle, you must watch out the intervals given from the questions. Okay, so here's the tips. Watch out intervals. Intervals of the solution. Okay, so verify and determine how many solutions that fit the questions or the equation given, or the equation that you have proved. Okay? Yeah, for C, its base angle is 32 degree and it wants fourth quadrant. So it wants the answer from here. Okay, assume it starts from the 360 degree from the positive x-axis, quadrant 1. Okay? So it's actually, the base angle is the angle we have to add up 360 degree. But why? Why? Okay? Because it starts from 360 degree to 720. Why it can't be 360 degree? Because the angle has rotated in a complete cycle once. So your theta must add up with the 360 degree plus 360 degree minus its base angle. Okay? Provided that you have to add up 360 degree for considering one cycle. The angle has made a complete one cycle. Then it starts to subtended its base angle. And it keeps going to the quadrant 4 and stops at quadrant 4. So here is the way to solve for the theta. Okay, so the answer goes to 688 degree. Okay, So for the first three parts of this question, its base angle is in degree. But for the last three parts, their base angle are all radians, are all in the form of radians. Okay, so for the D, B equals to pi over 4, and it wants third quadrant. It wants the angle subtended that stops in this region. Okay? Okay, I'm not going to shade too deep, too dark. So what is its base, its angle? Okay, watch out the intervals from 0 to 2 pi. So pi over 4 is 45 degree. But in radians, it is pi over 4. Okay. So to get the base angle, pi represents 180 degree plus pi over 4. Okay, this is the formula of finding the angle subtended, I mean the reflex angle in the third quadrant. I add up 180 degree and the base angle. So you have 5 pi over 4 as your final answer. Okay, good. E. B equals to pi over 3 and it wants second quadrant. Simultaneously, you have to look up what is its interval. It starts from 2 pi to 4 pi, which means that this angle has made a complete cycle. Okay, a complete cycle is 2 pi, which is 360 degree. So here is the pi over 3 and it wants second quadrant. So which means the theta equals to 2 pi first, then add up with y pi because of this angle is subtended from its positive x-axis and it goes a complete cycle, then it stops at the second quadrant. In the second quadrant. And this is the angle that we want to find. So it's pi because of this angle subtended by the straight lines minus away the pi over 3. So just press your calculators. You will get 8 pi over 3 as your final answer. Okay? So although this question seems very complicated, but if you keep practicing, okay, until you get sophisticated, and I'm sure you will have a strong grasp in the positive angles with its fundamentals. Okay, so for the part F, as the last part of this question, given the base angle is pi over 6, okay, it wants you to find its angle in fourth quadrant. Okay, this quadrant. What is this interval from negative 4 pi to negative 2 pi? Okay, so for the theta, it must be negative. Why? Is the theta can be only in between negative 4 pi to negative 2 pi, right? So we have to add up with the negative 2 pi first, then the pi over 6, right? So we should put negative because of add up. Or we can put a negative side in the outside, at outside, bracket with the 2 pi plus. Okay, so since it wants to find the theta in the fourth quadrant, so 2 pi minus pi over 6. So just press your calculators. That leads to final answer. 2 plus 2 minus 1 over 6. And then you will get negative 23 pi over 6 as your final answer. Okay? So yeah, that's the end of this question. So now let's proceed to the next question. Alright, let's move on to the next question, which is the question 6. Okay, given that the tangent A equals to negative 2 over 3 and cos B equals to 3 over 4 positive, where both angles A and B are in the same quadrant, and find the values of the following parts. Okay, first thing first, you have to know in the Cartesian plane, it consists of 4 quadrants. Okay, A, S, C, T, all sugar, coffee, and tea. Alright, so what does the A mean? Means that sine, cos, tangent are all positive in quadrant 1. For the second quadrant over here, sine is only positive, the rest negative. Quadrant 3, sorry, it's all sugar, tea, and coffee. My mistake. So for the quadrant 3, only tangent is positive. Quadrant 4, cos positive. Okay. So given that the cos B is positive, so as we know that the cos B is closely related to the, almost equal to the horizontal distance, which is the x-axis, which is parallel to the x-axis. So cos positive is quadrant 4, and coincidentally, not coincidence, this is the fundamentals, okay? Tangent is negative in quadrant 4. So only quadrant 4 matches for the both angles. So which means A and B are both the angles are both in the same quadrant, which is quadrant 4. Okay. So try to draw a triangle out. So now let's focus on in the fourth quadrant. So for the tangent A, it is negative 2 over 3. So which means the y direction is negative. Okay? So draw a line downwards. So this is your angle A. Okay? But actually we just need to draw a triangle to illustrate that the angle A is deflected from the positive x-axis, and where this is 2, 3, where this is negative 2, because we have to consider the directions of the negative angles. So let's looking for the sine A. So how to get sine A? Okay, so by using the Pythagoras theorem to find what's the side length of the hypotenuse. So I have to use the Pythagoras theorem. So for this, h equals to 3 square plus negative 2 square. So which is the square root of 9 plus 4, which is 13. So now we know that the hypotenuse is 13. What is sine A? Sine A is opposite over hypotenuse. So negative 2 over 13. But if you want to make the term of the 13 on the above, you can conjugate, it's up to you. Okay, so this makes your answer looks nicer. Okay, for the B, cos A. So of course cos A is positive since the cos is positive in quadrant 4. Okay? So which is 3 over 13. That's enough. Okay, because the 3 is the x coordinates, which is positive. So yeah. Okay. B. Let's take a look at the cos B. So given that the cos B is 3 over 4, so which means that the B is also the angle, the negative angle, which lies on quadrant 4. Lies in quadrant 4, sorry. 3/4, which means the ratio of the adjacent to the hypotenuse is 3:4, which is 3/4. So now the question wants you to find what is sine B. Okay, I want to get this length. So let's label it as L. So L is 4 square minus 3 square by using the Pythagoras theorem. So what is it? It is sub 7. So now we know that the L is sub 7, but is it right? Wrong, because of the angle B lies on the quadrant 4. So which means the y direction must be negative. Okay? So it is crucial to double check, make sure to avoid any case mistake. Okay, there we go. So how to get sine B, which is the ratio of opposite to hypotenuse. So the answer is -7/4. That's all. What about the part D? Part D is tangent B. Okay, tangent B is literally negative as well, which is -7/3. Opposite over adjacent. Okay. So I think this question is quite straightforward and nothing complicated so far. Okay. Right. That's the end of this question. Let's proceed to the next question. Okay. Let's move on to the next question, which is the question 7. It's also under the course book, but this question is about graph sketching of the Trigo functions. So there are 9 parts for you to sketch, but I only discussed 5 parts for you. Okay, the rest I need you to try it out by yourself. Okay, before we dive into this question, I need you to know that what is the pattern of the sine, cos, and tangent graph for each. So for the sine graph, okay, for the standardized of the Trigo graph, okay, let's take 0 to 360 degree as the standard intervals. The sine graph must look like this. What about cos graph? It is from up to down and then upwards. What about for the tangent? Okay, for the 360 degree, there are 2 asymptotes from 0 to 360 degree because of tangent is sine over cos. Okay, so when sine is maximum, cos is minimum. Okay, so for the cos becomes 0, sine is 1. So 1 over 0 is undefined. So you have the asymptotes. Tangent graph has 2 asymptotes. One is the first quadrant to second quadrant, and the third quadrant to the fourth quadrant. So the tangent graph should look like this, from 0 to 360 degree. Okay? So using these concepts, okay? So let's start from A. Y equals to 2 cos x. Okay. So remember that the transformations of the functions can be applied in the Trigo functions. So it turns out the result as the cos graph over here from up to down. And however, you don't have to draw it so accurate, as long you draw it like this, okay, to show that you have a strong understanding and grasp in the Trigo graphs. And then just label here as 2, like this, as well as the -2, to show that the cos x has stretched by a transformations, has been transformed by a stretch with the scale factor of 2, which is parallel to the y-axis or in y direction. Okay, that's all for it. What about for the B? Y equals to sine half x. Okay, so what about for the half x? It means that you just need to make a half cycle to reach 360 degree. So remember that what is the formula of finding its period? Which is, this is called period equals to 360 degree divided by b, where b is the coefficient of the x inside the psi function or any Trigo functions. So since the b is half, so which means that 360 degree times 2. So for the period, it is the twice of the 360 degree. So since it only wants you to draw from 0 to 360 degree, so we just draw a half cycle of the sine graph. That's all. So where its maximum value is 1, so that's the answer for the y equals to sine of the half x. Okay? So what about this? Let's jump to e. Y equals to 1 plus 3 cos x. So what you can see over here is it transforms from an ordinary sine graph, cos graph, stretch in y direction by scale factor of 3, stretch factor, and then it undergoes translation, or the entire graphs after the to move up 3 cos x by 1 for each y coordinate. So, which means that its center line or the center axis is no longer 0. No longer y equals to 0, but y equals to 1. So your graph will look like this. But to draw a proper graph, you can only make an imagination. Okay, because the examiners only wants you to draw the graph that is resulted from the transformations only, the final graph, not the graph in the process. Okay, because too many graphs, then the examiner doesn't know which graph is your final answer. So yeah, stretch like this, and then here you can state that here is the 1, y equals to 1, and what is its original maximum value? It's 1 times 3 plus 1, 4. For the negative 1 times 3, negative 3 plus 1, so negative 2. So here is negative 2 as its minimum value. That's all. Okay? But actually in the external examinations, you have to draw the size bigger. Okay, at least I think 75% of the space provided. Okay? And please draw the graph clearly. Make sure the graph not too truncated. Okay? Because if you do it this way, this benefits you with the higher score. Okay, for the part F, y equals to 2 sine 3x minus 1. Okay, apologize to my chaotic words. So, sine 3x, what does it mean? It means that it requires 3 cycles to reach 360 degree. So this is the stretch in x direction with scale factor of 1 over 3. So which means that the original sine graph will, for each x coordinate, must divided by 3. This is how it means. Okay? And the 2 refers to the stretch in y direction with stretch factor of 2, and it goes down by 1. So as you can see that the transformations must consider sequence or order. Okay. So let me draw the sine graph like this. 1, 2, and 3. Okay? Alright, oh sorry. I forgot to remind you that after you sketch the graph, okay, it is better for you to label at the x at which x coordinate, what is its value, what is its y values, okay, to make clear to the examiners. Okay, this also guarantees your higher score. Okay, make it like this. Now it looks better. And then just extend the line. There we go. Okay. And then it moves downwards by -1. So which means that its graph should look like this, where this is 1, because of after the maximum and minimum value are stretched by 2, multiplied by 2, and then -1. Okay, so meanwhile for the -2, -1, so its new minimum value is -3 right now. And so yeah, that's the final answer, where this is -1, of course. This is the 360 degree for the x, and for this center, it is 180 degree. So there we go. Okay, sometimes you must have a good imagination as well as your observation. All right. Okay, move on to the last part of this question we are going to discuss today. Part H. Y equals to 2 cos x plus 60. So first, think about the cos graph. An ordinary cos graph, you undergo the stretch first. So your cos graph looks like this. Okay, just draw, first thing first, just draw an ordinary cos graph first. Just that the minimum and maximum value must be 2 and -2 respectively. And then what's the difference over here? It is x plus 60. So which means that your cos graph must move 60 degree to the left hand side. Okay. So you know that this is 90 degree, this is 180 degree, as well as this is 360 degree over here. Okay? So since it wants to move the 60 degrees, so this original point from 90 degree must move to 30 degree. So at this point it's 30 degree. So move it like this. Okay? And then just draw the remaining one. So for me, when I'm using the tablet right now, I just move the remaining graph over here to the another side. Okay, because my tablet is beneficial for me to use because the shape tool over here benefits to my workings, to my productivity. Okay, so this is how your graph of the 2 cos x plus 60 looks like. And just erase the remainings. So don't forget to label the maximum and minimum values of this graph. This is 2 and this is -2. Where here is 30 degree. Okay? So yeah, that's the end of these questions that we discussed over here. So now let's proceed to the next question. Okay, here's the next question. It's still under the course book. So this is how the real external examinations comes out like. Okay, the actual official questions. Okay, we know that the Trigo, there's a Trigo functions. Of course, it also has the range and the domain, as well as this graph sketching representation. Okay, with the domains given, the intervals of the domain. So you have to get familiarized to the real questions. How does it look like? So let's start from part A. Okay, find the range of the f. So to find the range of the f, you have to use the domain over here. Okay, just perform it like this. So just modify from x to 4 minus 2 cos x. So what is cos 0? Cos 0 is 1. What is cos x? -1. So we can confirm that the cos x is from -1 to 1. Not confirm. It is original range of the cos functions. Okay? And then multiply -2 at both sides. Not both sides, it's all sides. So you have -2 to 2. Okay? Then add up by 4. So in the end, your range is 2 to 4. No, sorry, it's 6. Okay? Just state that the range of the f is 2 to 4 for the fx. To 6, sorry. So that's the answer. Okay? And hence, sketch the graph of y equals to fx. So just construct the two axes. Okay? Y and x. And then what is the -2 cos x? Which is, so of course, the negative refers to reflection and 2 refers to the stretch in one direction with the factor of 2. And then it moves up by 4 through translation. So which means that the fx is always positive right now. Okay? So this is 2, label it. And this is 6. Where the center line is 4. Because of its amplitude is 2 over here. Write y equals to 4, and then you can write y equals to 4 minus 2 cos x. So this is how the graph looks like for the graph of y equals to fx. Okay. Okay, part B. Explain why f has an inverse and find the equation of this inverse. Okay. So if you want to make fx has an inverse, so what I'm going to say is we must sacrifice some domains in order to satisfy that f has an inverse. Okay? To test that whether it has an inverse function, we must carry out the horizontal line test. So assume that the graph behind here is invisible right now, and using the horizontal line test, so as you can see that no matter how much the horizontal line moves up and moves down, it always intersects one point with the graph. So how to explain f as an inverse? Okay, we can write it in this way. So for the interval from 0 to pi over 2, wait, 0 to pi, sorry. So by right, your graph is drawn until pi only. Yeah. Makes sense. So we don't have to write the intervals. Okay. So why f has an inverse for the domains over here? Okay. So it is 1-to-1 relation for the domain 0 to pi. Okay, this is one of the acceptable answers to explain why f has an inverse. And there's another answer. You can say using a horizontal line test. Or a horizontal line only passes one point with the graph of fx. Okay? Or you can say it only intersects one point with the between the graph and the horizontal line. Okay? So as long you need to explain that f only has 1-to-1 relation, not many to one. And now we can not and sorry. It's then. So now let's find the f inverse of x, since we have known that fx has an inverse because of its graph is 1-to-1 relation for the domains we have sketched over here. So let the fx equals to y. So put the y equals on, substitute the y on the fx, and then equals to 4 minus 2 cos x, and change the subject from y to x. So now let's find the expression of x in terms of y. So this is how it works. 2 cos x, 4 minus y. Okay, y move to right hand side to get negative, and for the 2 cos x, move to the left hand side to get positive. Divided by 2 and both sides. And then take the inverse cos, arc cos. But in pure mathematics, just write the arc cos as cos cos, and then upper with the -1. Okay? And I don't encourage students or candidates to write arc cos as arc cos, because there are 2 letters of s. Okay, this makes you very confused. To avoid any unnecessary mistakes, just write cos and then -1 on the subscript. And then just rewrite the inverse of f as f inverse x equals to cos, arc cos of the 4 minus x. Why should we substitute y as the x? Because of, in the Cartesian plane, it only can involve f f inverse or fx and x. Okay, where these inverse functions only in terms of x, where x is a domain. So to avoid this careless mistake, you must do more practices in the inverse function, in the questions of the inverse functions, especially the past papers. So it is best for you to write the domain. So as you know that, what is the domain of the x equals to the range of the f inverse x. So similarly, just write the domain as 2 to 6. That's all. Okay? C. Sketch the graph of the y equals to f inverse x on your graph. So first thing first, you have to draw the inverse x, the inverse of fx. Draw a line over here. Okay? And usually, the question wants you to draw the fx and f inverse x simultaneously. So you have to draw a line y, a dashed line y equals to x for better analysis and illustrations of the relationship between fx and f inverse x. Okay, here is it. So when it comes to inverse fx, inverse of the f, domain and the range swap. Okay, so when x equals to 0, y is 2, so just change to here, 2. Okay, when it is pi over 2, when x equals to pi over 2, it is 4. You know that the pi equals to 3.14125 approximately. Okay. So just swap. So 6 must be somewhere here, I think. And for the pi, I think somewhere here. Okay. So this sketching is very is just a random sketching lah. But the concept must be correct. Okay. So usually for the f inverse x, it is reflected about the line of the y equals to x, usually lah. But not always. Okay. It's better for you to sketch the graph for better analysis. So when there's a pi over 2, it is let's see, it is 4. So 4 must be somewhere here. Okay, we can estimate the pi over 2, which is 1.57. Okay, I think I need to resketch again for the graph of f somewhere here. (1.57) for the pi over 2. So I will mark the point over here. Okay. And although it's not accurate, but this is for your understandings. Okay. So your inverse graph must look like this by right So there we go. Here's the inverse of the graph. Okay. Okay. I think I was wrong now. Yeah, this is the proper the proper graph of the y equals to f inverse x. Okay, where this is the y equals to fx. So yeah, as you can see that the f inverse x is just the reflection of the fx, particularly for this question only. But I don't know how how do the fx and f inverse x for the other functions relate? Okay, by using the y equals to x. So it depends on how much question that you have seen, how much question that you have done before. Okay. So yeah, we have end the question. So we have end this question already. I mean the discussions. So this is the questions of this is the last question before the challenge part. And now let's proceed to the first question of the challenge part. Okay. Okay, let's move on to the next questions, which is the question 15. Also, this is the first question of the challenge part among the exercises for chapter 5. Okay. So we have two more questions to discuss from the course book before proceed to the passive questions discussion for these exercises for chapter 5. So this question is about the Trigo identities proving. Alright, so in the AS syllabus, okay, when you are taking the pure maths paper 1, what you can do is, what you are dealing with the Trigo identities is, you can only use the two identities that you have learned from your AS syllabus, which is sine square theta plus cos square theta equals to 1 and tangent equals to sine over cos. But no worries, these two formulas exist in the MF19. So when you are dealing with the Trigo identities, okay, it is best for you to own yourself MF19. Okay, so that in case you forgot the identities or the formulas, you can refer to it. Okay, at least to obtain the marks. So now let's prove 1 over sine theta plus 1 over tangent theta bracket squared is exactly equal to 1 plus cos theta over 1 minus cos theta. So usually for the Trigo identities proving, you must prove from left hand side to the right side. But it's optional for you, as long you have successfully proved the identities from the question given. So for this, I'm not going to expand because this makes me confused. So what I can do is remain it inside the bracket square. So use the identity of tangent theta equals to 1 over sine over cos. Okay? And then let the cos as the numerator. Like this. Alright? And then combine this together since both terms have the same denominator, have the denominator in common. So which is 1 plus cos theta over sine theta. Voila. Okay, that's easy for you to expand conveniently. So to expand sine, expand this expression for the numerator is 1 plus 2 cos theta plus cos square theta. What about for the sine square? It is sine square theta. Okay. And what's next? It is to let me see. So this is sine square theta by using the Pythagorean identities. Transform it into 1 minus cos square theta. Okay? Oh wait, I think you don't have to expand the 1 plus cos theta. Okay, just remain it like this. Only take the square for the denominator of the sine square and change it by modify it by using the Pythagorean identities. Okay, and then you may use the expression of the a square minus b square equals to a bracket a minus b bracket times the a plus b bracket. So now since there is only a term cos theta, so this makes your job easier. So just factorize it as 1 plus cos theta times the 1 minus cos theta. And then as you can see that there is a factor which is common for both numerator and denominator. And what to do is you just cancel out. And then just write out the result of the answer from the question given. So until here, this means that you have successfully proved the identities. So therefore, proven. Okay, so this is how you prove the Trigo identities by using the AS syllabus. Using the knowledge from AS syllabus that you have learned. So B, hence solve the equation of the bracket square of 1 over sine plus 1 over tangent equals to 2. So just basically use the result from A, okay, equate 1 plus cos over 1 minus cos that you have proved from A, the results from A equals to 2. And then you expand it, which is 2 minus 2 cos theta. Simplified the expression of the cos theta. Okay, let the cos theta as a subject. So you have cos theta equals to 1 over 3. And then take a look at the quadrants. I mean the intervals given is from 0 to 360 degree. So what you can see is the cos theta is positive. So just bracket beside here. So it has the solution of angles of quadrant 1 and quadrant 4. Because of only 2 of this quadrant is positive for the cos theta to satisfy this equation. So take the arc cos of the 1 over 3 and press your calculators. But what the question given here is the intervals of the theta, intervals of the degree. So make sure that the angles you need in your calculator is in degree, not radian. Alright, if you put radian, it may deduct your marks. So the angles, the one of the reference angle solution is 70.5 degree. And then don't forget to take your base angle 360 degree minus the base angle that you have found. That is for your solution for the angles for quadrant 4. In quadrant 4. So by right, you will get 289.5. Okay, for the standardized answer of the angles must be in 1 decimal place only, no matter how much of its angle. Alright, so there are 2 solutions over here. So, okay. I feel like this question may confuse to other candidates, but same as what I tell you last time, any hesitations, just reach out to me. Okay? So yeah, let's proceed to the next coursework questions, which is under the challenge segment before the passive questions. Okay, next question is the question 16. It's under the challenge segment. So this question is about the angles between the 2 lines, where the 2 lines are both linear. So this is what I taught you just now. Okay? Finding the angles by taking its gradient And we know that the gradient is equal to tangent theta because of the gradient is change of y over the change of x. So same as the definition of the tangent, which is the opposite over adjacent, where the adjacent side only touches the angle. Okay. So what should you do right now? It's just rearrange to the form of the y equals to mx plus c, or the gradient form. Okay. So you have obtained that the first gradient is -2. So which means in the Cartesian graph, its slope will look like this. Okay, -2 with the gradient of -2, which is the negative slope. Okay, for the another line, which is y equals to 3x plus 1. So you've obtained the gradient 2 is 3. So which means that the angles, I mean the second gradient is the positive slope, which is steeper than the magnitude of the first gradient. And this is the angle it wants to find. It wants you to find. Okay, just use the formula from the double angle formulas proved of the tangent theta. M2 minus M1 1 plus M2 M1 plus M2 times M1. Okay? 3 minus 2. I think M1 minus M2 will be better. Okay? So you must memorize this formula because this formula does not exist in your MF19. Okay? So just apply the formula inside to get the angles between the two lines. -2, 3. So we have theta equals to arctangent of the one. So the answer of the theta is either 45 degree, or you can leave it as the radians, which is pi over 4. Alright, so both angle units are acceptable. Okay? So that's the end of these questions. So now it's time for us to proceed to the puzzle questions. Okay, it's time for the puzzle questions, which is under the challenge part. So question 18. This is the question from 9709, May-June 2005, question 7, paper 1. Okay. A function is defined as f maps to x to get 3 minus 2 sine x for 0 degree to 360 degree, and find the range of f. Okay. So I don't think it's useful to substitute using this interval modified into this one, because sine 0 is equal to sine 360 degree. Okay? So instead, you can use your understanding that what is the maximum and minimum, what are the maximum and minimum values for an ordinary sine graph. So sine x max equals to 1, and then sine x min is -1. Alright, so fx max equals to 3 minus 2 times 1, and then 1. Fx min is 3 minus 2 minus 1, which is 5. So which means that it is upside down because of the -2 over there. Means that maximum becomes minimum, minimum becomes maximum. Okay, it's swapped. Both are swapped. So this is the minimum. Meanwhile, this is maximum. So just put that the range of f is from 1 to 5. That's all. Okay? Okay, part 2. Sketch the graph of the y equals to fx. 3 minus 2 sine x. So as I said before, the sine graph has reflected and then stretched by 2, and then finally the negative 2 sine x graph moves upwards by 3 in one direction. Okay. So as you can see, the range that you have solved over here is from 1 to 5. But I may diminish the part 1, the workings for part 1. Okay? To allow me to perform the workings of the graph. So this is x and y. Don't forget the label. And it starts from 1 to 5 with the amplitude of the 2. Okay? 1, 2. I think here is 2, 3, 4, and 5. No, I think this is way too short. Let's set here as 1, 2, 3, 4, 5. So where 3 is the center line, and here is the sine graph, here is the cos graph. So finally, okay, as you can see, the inside of the x inside the sine does not change, so which means that the period also does not change. So therefore, the result of the sine graph is like this. Will look something like this. Okay, don't forget to label its x coordinate with this is 2 pi. No, not 2 pi, it's 360 degrees. Since the question given is in the domains given are in the degrees, angles in degree. Okay, so this is 180 degree. So yeah, this is how its sketch looks like. Okay. So there's another function g is defined. G maps to x to get 3 minus 2 sine x for 0 to a, where a is the constant. State the largest value of the a for which g has an inverse. So in order to so as you can see that the gx has the function which is exactly the same as the fx, just that it has the function g has a different domain compared to the fx. So in order for the gx has the inverse function, what we can do is the sacrification of the domains. So draw a line over here. As you can see, the graph for the half cycle of the graph, okay, it does not have inverse because of when you are doing the horizontal line test, it intersects 2 points with the graph. Okay, so in order for the graph which only intersects with any horizontal line over there, we must do sacrification. So find out the a is 90 degree because of the half of 80. So for the third part, a equals to 90 or 90 degree if you wish. Okay, for which the g has an inverse. Okay, fourth part, where a has this value, obtain an expression for the inverse gx, of course in terms of x. So you can say to find the inverse gx, inverse of g, let the 3 minus 2 sine x equals to y. Change the subject for the expression of x in terms of y. 3 minus y divided by 2 equals to sine x. And then take the arc sign on the right hand side. Okay? And then finally rewrite the expression of the inverse gx. Alright, so that's all for this question. Okay. So yeah, every time when you have successfully solved the inverse function, make sure to change back the y to x. Okay, so yeah, that's the end of this question. Okay, let's move on to the next question, which is the question 20. So this is the past questions from 9709, May, June 2009, question 4 from paper 1. Okay, so I think this is beneficial for you because of the graph is given and just that you need to state out what is the values of the coefficients A, B, and C. Okay, part 1. For A represents amplitude. Okay, for each sine and cos graph, now it's targeting the sine graph. So as you can see, this vertical distance is 6 as well as the below. So which means amplitude is 6. So therefore, A is 6. B. Okay. B represents the period or the numbers of the cycles has to make in order to reach 2 pi. Because of the standard or complete cycle is from 0 to 2 pi. But now, it has 2 cycles, so therefore B is 2. Okay, C. C is the vertical shifts or the vertical distance that the graph moves up. So since the center line, the center equilibrium axis, no equilibrium lah, I think center axis is no longer 0 but 3. So which means the entire graph moves upwards by 3 units. So therefore, C equals to 3. That's all. Now let's proceed to the part 2. Find the smallest value of x in the interval for which y equals to 0. So you have to equate. So since you know that the clear equation of the graph, which is y equals to 6 sine 2x plus 3. Okay, for the y equal to 0, so just equate. So just equate equate 6 sine 2x plus 3 equals to 0. Okay? So you found that the sine 2x is negative 1 over 2. It is only in quadrant 3, and quadrant 4. Okay, so since the question 1 is the smallest one, so the smallest is quadrant 3 only. Quadrant 4 is not accepted. Okay, because of quadrant 4 is not the smallest. So find the arc sine first. Okay, remain the 2x. Find its arc sine of its value. What is it? It is 2x equals to okay, since the interval given is in radian, so we have to convert the angle units to radian. So which is 7 pi over 6. And then divide by 2, which is 7 over 12 pi. And this is the smallest values of x. So that's all for this question. Alright, let's proceed to the next question, shall we? Alright, let's move on to the question 23. Okay, which is also the past questions. So this is from 9709, May, June 2007, question 3 from paper 1. So this question is about the Trigo identities proving. Okay, prove the identity 1 minus tangent square x divided by 1 plus tangent square x equals to 1 minus 2 sine square x. Okay. So, as the same I taught before, we can only use the two identities listed from your MF19. So, tangent x equals to sine over cos. So, use this fact inside this identity provings, which is the sine square. Replace the tangent square as sine square over cos square. Sine square x divided by cos square x, as well as for the denominator. Okay, so for the 1, multiply, replace 1 as cos square over cos square. Okay, to satisfy the each denominators, like this. Okay, and what's next is combine these two together, since all of them have the same denominator. So you will get cos square x minus sine square x divided by cos square x divided by cos square x plus sine square x divided by cos square x. So as you can see that both numerator and denominator have a factor in common, which is the 1 over cos square x. So just cancel it out. Simultaneously, you can see that there's a Trigo identities. So just replace this as 1. So what you left right now is cos square theta, cos square x minus sine square x. But what the question shows over here is the result of the answer from the questions only has the term of the sine square. So to get rid away the cos square, we still need to use the Trigo, the Pythagorean identities. Okay, so just replace it as 1 minus sine square x and then minus sine square x. Okay, so just simplify it as 1 minus 2 sine square x, so therefore proven. Okay, so I think this question, this Trigo identity proof question is quite direct. Okay, nothing to discuss over here, so let's proceed to the next question. Okay, move on to the next question, which is the question 27. It's also the past questions from 9709, October, November 2003, question 2 from paper 1. Okay, first part. Show that the equation 4 sine power 4 theta plus y equals to 7 cos square theta may be written in the form of the quadratic form shown over here, which is 4x squared plus 7x minus 2 equals to 0, where x equals to sine square theta. So this is as the quadratic term, just like you substitute the sine square theta as x. So this is how does it carry out. So starting from 4 sine square, sine power 4 theta plus 5 equals to 7 cos square theta. So as you can see that the answer it wants is the x can be only in terms of sine square theta. So what you can do is to get rid the cos theta by using the Pythagoras identity. So just replace the cos square theta by 1 minus sine square theta. Okay? And then multiply by 7. And hence simplified into the quadratic term like this. Okay, negative 7 sine square theta can move to the left hand side to make it positive, and 5 minus 7 is negative 2. Okay, as you can see that there's a coefficient of 4, 7, and a constant -2. So this result suits the answer above. But we have to do another extra step, which is substitute away the sine square term, like this. Okay. So as you can see over here, the sine square term can be replaced by x. So x, you can say x equals to sine square theta. Sine square theta, okay? So it is replaced by x. So you have 4x squared plus 7x minus 2 equals to 0. Therefore, shown. So until here, you have successfully proved that the equation can be modified into the form of quadratic equations, okay, which equals to 0. Where the x you have substitute is sine squared theta. Okay. So for the part 2, hence, what is the meaning of hence? It means that you have to use the result from the first part, okay, in the same questions. So second, it wants you to solve the equations that you have proven from here to here. So first thing first, just rewrite the equation, the result of the equation that you have proven from part 1, and then solve the quadratic. Okay? So it is easier for you to carry out the factorization. You can use your calculator to evaluate it, and then solve for the roots of the x. But watch out, solve the equation, okay, where the equation only has a term theta. So which means that x isn't the solution that you want to find, but theta. Okay, recall that what is the x? The x equals to sine square theta. So in the end, its original solution is theta, so you have to substitute back by sine square theta equals to 1 over 4. Meanwhile, for the x is x equals to -2, and then sine square equals -2. But every math student knows that it is impossible to square root the -2, because if you take square root for the negative, it will form the complex number. Plus, sine theta is impossible to be have its magnitude which is greater than 1. So we have two reasons to argue that this does not have solution. First, it does not form a real solution but complex. Second, its magnitude is greater than 1 or less than -1 for the -2. Okay, so despite the sine function has been squared, but still its minimum and maximum values is from -1 to 1. Or its magnitude is 1, or the maximum value. Okay? So we may ignore this one. Just focusing on the 1 over 4th, because the 1 over 4th is positive. Plus, it suits the range of the sine theta. Okay? So take the square root at both sides, you will get sine theta equals to plus or minus square root of 1 over 4. So divided into two cases, which is the 1 over 2 and the sine equals to -1 over 2. So until here, this equation is possible. This equation is also possible. Why possible? Because both equations have their respective solutions. So now it wants you to solve the theta from 0 to 360 degrees. Okay, for the positive sign, this theta lies in quadrant 1 and quadrant 2. For the negative, it lies in quadrant 3 and quadrant 4 from 0 to 360 degree. So, okay, so I assume you that you have know what is its exact value of the theta. For its sine theta is 1 over 2, which is 30 degree. How to get the angle subtended for the quadrant 2, which is 180 degree minus 30. But in actual exam, you don't have to show the workings of the how does this angle come from. Just write the result of the answers, that's enough. Okay? So as you know that the marking scheme does not demand you too much and too harsh. Okay? So for this theta, it is literally 180 plus 30 for the third quadrant, which is 210 exact value by right. For the quadrant 4 is 360 minus 30, 330. So hence, this equation has 4 solutions of the angles, which is 30 degree, 150, 210, and 330. Okay? That all 4 of these are inside the range of it. Okay? Inside the range of the domain over here. So yeah, this is the tactics for you to solve the equations that involves multiple angles. Okay? So yeah, this is the best example. Okay, let's proceed to the next question. Okay, move on to question 28. This is the puzzle questions from 9709, October, November 2004, question 6, paper 1. From paper 1. The function of f maps to x to get 5 sine square plus 3 cos square x is defined for the domain from 0 to pi. Okay, find the fx in the form of a plus b sine square x and also in the same time you need to stating the values of a and b. Okay, first part. Fx equals to 5 sine square x plus 3 cos square x. So it only wants you to leave your answer of fx only in terms of sine square x. So to get rid of it, which is the cos, because it's different, you have to use the Pythagoras identity to carry it away. So substitute the cos square x by 1 minus sine square x. Do it this way. So we have 5 sine square x plus 3 minus 3 sine square x. Okay? Sort, rearrange in their sort and simplify it. 5 minus 3 is 2, so 3 plus 2 sine square x. So that's the answer for the fx, only in terms of sine square x. And also you need to state what's the value of a and b by the comparison. A equals to 3 and b equals to 2. That's all. Okay. Second part. Hence, find the values of x for which the fx equals to 7 sine x. So just equate fx to 7 sine x, or the 3 plus 2 sine square x equals to 7 sine x. So as you can see, there's a sine square x and a sine x. So it is the quadratic expression or the quadratic term, where the solution it wants to solve is sine x first, and then you find for the x. So we have 2 sine square x, move the 7 sine x to the left hand side, so it's negative 7 sine x plus 3 equals 0. Okay, so for me, I'll directly solve for the equations, but for your understanding, I'll say let's say p equals to sine x. So what I modified here is 2p squared minus 7p plus 3. Use your calculator to solve it, but for the factorization, you have to use the calculator, find the roots first, and then make it the bracket. Okay? So this working must be shown in order to avoid the marks deduction. Okay, 2p, so you get 2p minus 1 bracket, and then the bracket of p minus 3. Okay, the p is 1 over 2 and 3. Okay, recall that the p equals to sine x, so substitute back as sine x equals to 1 over 2 and sine x equals to 3. But it is impossible for sine x equals to 3 because of it 3 has been exceeded the range of the sine because it exceeds 1. Okay, remember that the range of the sine functions is only from 1, -1 to 1 unless there's a translation. Okay? So now let's solve for sine x. Okay, this seems it has an exact value for the x, so it is from quadrant 1 and quadrant 2. But before we solve for x, let's take a look at the what's the range. Okay, range is from 0 to pi, which is quadrant 1 and quadrant 2. That suits the condition over here, and this makes your job easier. So we get this time we can't leave your answers. We can't leave the answers in the form of degrees, but radians because of its interval shows the angle units in radian. Okay, so what is 30 degree in radian form? Which is pi over 6, right? And how to get the angle subtended in the quadrant 2, which is pi minus pi over 6. Okay? Which is 5 pi over 6. So that's all for this part. Okay, C. State the range of the f. So, restate the fx is 3 plus 2 sine square x. So, to find its minimum value, okay, we know that sine square x is always positive times 2, positive, and plus 3. So, which means this function is even more positive. So, which means that this is always positive, so we can confirm that fx must be greater than 3. I mean, must be at least 3. Okay? And what about its maximum value? So substitute the sine square x equals to 1. So this is your maximum fx value in order to find the range. So it's 5. Okay, you can say that the range of the f is from 3 to 5. That's all. Okay? There's only a mark for the range of the f that you have stated over here. Okay, so yeah, that's the end of this question. Let's proceed to the next question. Okay, let's move on to the second question of this discussion over here. So this is the question 30. It is a past questions from 9709, October, November 2010, question 4 from paper 13. Okay, so let's solve for the first part. Prove the identities of sine x tangent x divided by 1 minus cos x is equal to 1 plus 1 over cos x. Interesting. So usually the style of the Trigo proof is from left hand side to right hand side. Okay, this is the best encouragement. Okay, we can't just directly simplify over here, but instead, what is the tangent x? Ask yourself. It is the sine over cos, right? Sine over cos. And here it is. So what will you get is the sine square x divided by cos x, and then divided by 1 minus cos x. Okay. And then let the cos x multiply by 1 minus cos x over here. So you get sine square x divided by cos x minus cos square x. Okay. Wait a minute. I don't think this step will lead to answer, but I have some better ways. So just remain the cos x outside the product of 1 minus cos x, and ask yourself again, how to replace sine square x? Okay, just use the Pythagoras identities, which is 1 minus cos square x over the cos x plus 1 minus cos x, and then factorize 1 minus cos square x by 1 minus cos x 1 plus cos x. Okay, this is the way how you prove it, and then cancel out the both of the 1 minus cos x because they have the common factor of 1 minus cos x for the both terms, for the both numerator and denominator. Okay, so now you have 1 plus cos x divided by cos x left. Okay, so divide into 2, you will get 1 over cos x plus 1. Because of the cos x, the cos distributes to the second term. So cos x over cos x can be cancelled out to get 1. And then rearrange, that leads to the answer given from the question. So therefore, proven. Okay. So usually for the Trigo proof, it costs 3 marks. Okay. If you are not able to obtain these 4 marks over here, what you can do is to use the result from the question given to do this question. Okay, hence, solve the equation of this thing plus 2 equals 0. So it just literally, the result that you have done, 1 plus 1 over cos x plus 2 equals 0 from the A. Okay, so 1 over cos x plus 3 equals 0. Okay, so move the 3 to the other side, so we get 1 over cos x equals to negative 3, and then swap, or you take the powers of negative 1, so we get cos x equals to negative 1 over 3. So I think some of the candidates do not know how to get this. So this is the way. 1 over cos x equals to 3. Because of negative 3 has a denominator of 1, so you have to swap the positions. Cos x divided, move to upwards to get multiply. Negative 3 multiply moves to the other side, which becomes divide. So you will have cos x equals to negative 1 over 3. Okay, so hopefully this makes clear for you. Okay, so what is the interval of the x is from 0 to 360 degree, but for the cos x is negative, so which means that only quadrant 2, the angles of quadrant 2 and quadrant 3 are present. So take the arc cos. What do you get? By pressing your calculators. Okay, make sure your angle units is in degree, since the interval given is in degree. So its base angle is 70.5, but 70.5 isn't our answer. So you have to take 180 degree minus the arc cos of 1 over 3, so you get 109.5 as the first final answer. For the second, for the quadrant 3, it is 180 degree plus arc cos of 1 over 3, which is 250.5. Okay, so yeah, that's all for this question. Okay, let's proceed to the last questions among our discussion today. Okay, it's time for the last questions among our discussions today. So this is question 33. It is a past questions from 9709 May June 2010. Question 11 from paper 1-2. Okay. The function f maps to x to get 4 minus 3 sine x is defined for the domain of the x from 0 to 2 pi. For the first part, solve the equation fx equals to 2. Okay, so for the first part, fx equals to 2, where fx equals to 4 minus 3 sine x. Okay, so let the sine x as the subject, so you will get 4 minus 2 is, or negative 2. So as you can see, the negative can be cancelled out, and then you leave the sine x equals to 2 over 3. Okay? So following the intervals from 0 to 2 pi, since the sine x is positive, so the two solutions lie on each quadrant, which is quadrant 1 and quadrant 2, since the sine x is positive right now. Okay, take the arc sign to get the solutions you want. So since the angle is in radian mode, make sure to convert the angle units in your calculator. And then you will get 0.730 radians with the pi minus the arc sign of the 2 over 3. So you'll get 2.41 as your final answers. Okay, part 2. Sketch the graph of the y equals to fx. Okay, so actually I have drawn the graph earlier. There you go. So this is how does your graph of fx equals to 4 minus 3 sine x look like. Okay, so following the examiners, negative means the reflection of sine graph. So you must show that there's a reflection for the sinus, the sine graph, and then 3. 3 means the amplitude stretch, which means that each vertical distance for here and here must be exactly the same. Third, you must show to the examiner that your graph has shift upwards by 4 units vertically. So which means that your starting point of these functions is from 0, 4. Okay, following these 3 transformations or the conditions, and it is enough for you to obtain full marks for the graph sketchings. Okay, okay. Question. Third part. Find the sets of values of k for which the equation fx equals to k has no solution. So just equate fx to k, or 4 minus 3 sine x equals to k. Right. So negative 3 sine x equals to k minus 4, and then divided by negative 3. So you have 4 minus k divided by 3. So recall that what is the range for the ordinary sine function, which is from negative 1 to 1, right? So since it doesn't have solution, we have few possible set of values. First, it is for so for the sine x does not have solution. There are 2 possible set of values. First, sine x must less than negative 1, or the sine x must greater than 1. Okay, so equate the sine x to 4 minus k over 3, which is lesser than 1, and hence you solve the both inequalities. Okay, so we have 4 minus k. Okay, let's solve it one by one. 4 minus k, the 3 move upwards, or multiply 3 on both sides, so we have negative 3. Okay, the 4 can be move to the right hand side, so we have negative k is less than negative 3, negative 4, negative 7. To cancel out the negative, you must change the sign. Why? Because of the magnitude of 7 is greater than 7 probably. So this is the first set of values for the k, following these conditions that I have implied over here. Okay. Okay, for another set of value of k, it is 4 minus k divided by 3 is greater than 1. Okay? So 3 minus 4 is negative 1. So therefore, there's another set of value of k is k less than 1. So that's the second solutions. I mean the second set of values. Okay? By right, you have the two answers of the inequalities for the third part over here. Right. Okay. Move on to the next part. The function g maps to x to get 4 minus 3 sine x is defined for the domain from half pi over 2 to a for the x. Okay, as this domain. So as you can see, this pattern of the question is similar as the previous question that we have discussed just now. It is both functions have the same functions, just that they have the different domains. Okay. So for the pi over 2 to a, and for pi over 2 to a, so which means that there's a sacrification of the domain. So now let's sacrifice the domains first. Wait. For the better illustration, maybe I copy the graph first to solve for the part 4. So for the part 4, it is about the analysis of the whether G has an inverse. Okay? And also you need to state what is the largest values for A in order to say that the G has an inverse. So here's the graph. So now let the y equals to G, and I may erase away some domains over here. Sorry. Okay, here it is. So this is the pi over 2 to, what is the A? So I want the midpoint from pi to 2 pi. So it's obviously 3 over 2. Okay, in order for the gx has an inverse. Why? Because of using the horizontal line test, it only passes through one point with the graph. Or the function gx is a one-to-one relationship. So using either one of the reasons to answer the explanation that g has an inverse, but this question doesn't require you to write the justification. It just wants you to state what's the value of A in order for G has an inverse. Okay. So of course, for the upper one, we have to do some sacrification of the domain over here. So voila, there is it. Okay, obviously the A is 3 over 2 pi. There you go. And also it is best for you to restate what's the range, what's the domain of the gx function g. Okay, this is the answer. Well, let's solve for the last part 5. For this value of A, find the g inverse of 3. Okay. So some people think that I have to find the G inverse of x and then substitute by 3. Okay, can. This is one of the method, but for me, I would say G3 equals to x. But if you convert back, it is Gx equals to 3. So which means that you don't have to waste your time to looking for what's the what's the g inverse x and then substitute by 3. Of course, if you want to do it so, okay, it's up to you, go on. But for me, I provide an alternative method over here. So the gx equals to 3, so which means that 4 minus 3 sine x equals 3. So negative 3 sine x equals to negative 1. Therefore, sine x is 1 over 3. Okay, so for the given interval, it is only from pi over 2 to 3 pi over 2. Take the outside at the both side. Not both sides. Take the outside of the 1 over 3. Okay, by using the calculator, press it, see how much you get. By right, it only has one solution. Remember to convert the angle units to radian, of course. So your final answer is 0.340. That's your final answer. Okay? But for the normal methods, I give it to you right now. So to find the g inverse x, let the y equals to 4 minus 3 sine x, and then rearrange, let the x as a subject in terms of y. Okay, 4 minus y divided by 3, and then sine x, and then equals to sine x. And then take the outside. So in the end, the result still will be the same. So you got g inverse x equals to outside of the 4 minus x divided by 3. And then for the g inverse 3 is just outside of the 4 minus 3 divided by 3. Or the sine, or it is the outside of the 1 over 3. So in the end is 0.340. Okay? So which means this g inverse is same as this one. Okay? But there's a risk for the alternative method. You can't say that the x equals to 340. Okay? In the end, you have to make clear to your answer that the g inverse of 3 is equal to 0.340. That would be better and neat. Okay? So to lower the risks, I suggest you to use the method for the normal students over here. So this is method 1, and then this is method 2. So in conclusion is, this method is recommended. So yeah, that's the end of this question. Okay, so as the same, the rest of the question, I need you to try it out by yourself, okay? After I have end the lecture and discussions for the pure mathematics one, maybe I will somehow I plan to post the solutions of the exercises for chapter 5, 6, 7, 8. Okay, so yeah, I declare that chapter 5 trigonometric has officially ended. So let's move on to the summary for the chapter 5. Alright, here comes to the summary for the chapter 5 trigonometric before we end this video. Okay, first, you have to know that each trigo ratios that comes from your secondary school knowledge, okay? So I'm not going to explain that much. So sine is opposite over hypotenuse, cos is adjacent hypotenuse over hypotenuse, tangent is opposite over adjacent, okay? Or we can use the memorizing method, which is stochastic, because of DOA, CAH, SOH. Okay? D means tangent, O over A, C means cos, A over H, S means sine, O over H. Okay? So, where the theta as the base or reference angle of the right angular triangle over here. Okay? Whether the angle light which undergoes anticlockwise or clockwise direction. And remember that anticlockwise is taken as positive angle whereas the clockwise is taken as negative angle. Okay? And next, some certain values that come from the definitions of the unit circle of the trigonometric ratios, where for the unit circle its radius is 1, that which is standardized. Okay, so for the positive angles, get to familiarize how to find the angle lines for each quadrant. Quadrant 1, all positive; 2, sine positive; third quadrant, tangent positive; and the fourth, cosine positive. Instead, you can use this method of the memorization, all sugar, tea, and coffee, ASTC. Okay, so what is the alpha? Alpha is the obtuse angle if you want to take theta as the base angle. So these two angles are known as complementary angles because some of them is 90 degree or pi over 2. Okay, so read through 3 of these by yourself. Okay, where 2, 3, 4 for the theta angle is greater than 90 degree or pi over 2. Obtuse angle is more than 90 degree but less than 180, and the rest, third and fourth, are the reflex angle, which are both almost closer to 360 degree. Okay, so for the trigonometric functions, what's the difference between the sine and cosine? Let's have a compare and contrast. Okay, so both graphs are the sinusoidal wave, just that they have the quarter cycle difference. Okay, when you shift the quarter cycle to the left hand side is x plus pi over 2. So to get the cos function. Okay, if otherwise it shifts to the right by half cycle. I mean the quarter cycle. Okay, both are continuous or endless domain, as well as the x is real numbers, and the range is from -1 to 1 because of their original their base definitions. As well as the period, you need to get to familiarize, and also the periods. Okay, period is closely related to the range. Okay, so this is the summarized form. You can refer and see. Okay, sorry, there's a mistake that yeah, I don't think there's a mistake okay. So for the tangent function, it is different because of it is non-continuous. Following the tangent definition is sine over cos. So when the cos is 0, sine is maximum. When the sine is minimum, cos is maximum. So this is the sine maximum, cos is minimum. This is sine is minimum, and this is cos of minimum. Maximum cos, minimum cos, minimum sine. Sorry, this is the 0 is a maximum sine, minimum sine, maximum sine, minimum sine, maximum sine, where this is the maximum cos, minimum cos. So for each asymptote, the cos is minimum for the tangent function. That's why it is a non-continuous, because for the domains, no matter how much is it, pi over 2 plus how many m times, okay, all of the domains do not define the tangent functions. And this will form an asymptote. Okay? So you must get to know that sine function and the tangent functions are odd functions, where the cosine functions is a even function because of there's a graph which resembles quadratic, but in fact it is under the Maclaurin series. Okay. So for the transformation of graph, I don't think I need to explain for you much. These below are just for visualizations for the understanding. Okay. So anyway, Trigo functions are considered as a functions, okay, which is applicable by the transformations of the graph that you have learned from chapter 2. Okay, which only consists of translation, reflection, and stretch in AS syllabus. Okay? So for the trigo identities, these two have been shown from the MF19, so I'm not going to cover you too much. For the solving trigo equations involving the multiple angles, with such like the sine of the any transformations of the theta equals to some real values. Okay, solve for the outside first for the few intervals before get to the theta answer. Okay, this is how the way you solve. Okay, which this method is standardized by the mathematics and further mathematics as well. Okay, and for the inverse trigo functions, okay, to define that it is one-to-one functions, it requires the sacrification of some domains to define its validity. What is its validity? Same as the chapter 2 that we have recalled, which is one-to-one functions, or to satisfy the horizontal line test, to make the horizontal line test valid. Okay? So yeah, for the domain and the range of the outside, for the inverse trigo, all of the 3 inverse trigos have been shown in the MF19. You can refer and see. And lastly, the angle between 2 straight lines. Okay, for the AS syllabus, you don't have to imply that the double angle formulas for the tangent exist or is used to prove that the angle between the 2 straight lines is this formula, just that you need to memorize this by yourself. Okay, and we may, following the 2 similar definitions, we can conclude that the gradient is tangent theta. Okay, so yeah, that's the end of this chapter. So in the next video, we are going to enter the new chapter, which is the chapter 6 series. But before this video ends, I'm going to cover you some our new subjects or the new contents in this YouTube channel. Okay, here it comes. By Jonathan Goldfish Education present. Okay, so which means that in my content of this YouTube channel, further maths is available right now. Okay, but for the first, I'm going to touch the paper 1, which is the further pure mathematics one with the subject code of the 9231. Okay, so as you can see from my contents of the YouTube channel, I have posted the Google Drive link to access these notes for the first chapter of the FP1, Roots of Polynomial Equations. Okay, go through by yourself. If you feel like all of the notes given over here is able for you to understand, please do some exercises if you wish. Okay, go on. And of course, if you have any questions, please reach out to me without hesitations. Okay, so yeah, that's the end of this video. Be sure to like and subscribe to my YouTube channel with the bell for the further updates. I will see you in the next video. Goodbye.
Thank you for watching this video. Be sure to like and share this video and subscribe to this channel. I will see you in the next video. Goodbye.